Welcome everybody to this Builders Social. This one is on retrofits. That's the theme for this month. I see some of you had already attended the Architects webinar earlier in the month, so welcome back. Just briefly to introduce myself to anyone who doesn't know me, I am Jessica Ayers. I'm on the board of PHINZ, and I'm really winging it this week because I've just spent the last 8 days moving house. So apologies if I'm not particularly polished. It's all been a bit last minute. So just some housekeeping. This session is recorded. And it will be on YouTube, probably, Nikki says, within the next 24 hours. It is awesome for the speakers if you can leave your cameras on, because it just makes it easier for people to identify with their audience. But we understand if you would rather not have your camera on as it's being recorded. So we have 3 wonderful speakers with us today. We're going to jump right into it, and we're going to, first of all, we're going to talk to Terry Bryers, and then we will talk to Matteo Garbagnati again. He was our speaker at the last session, and then we will wrap up with John Davies. And then after that we will have a Q&A session for as long as we want to go for. Please do put your questions in the chat. Write them down. You can raise your hand once we get into the Q&A session, and we just want to keep this informal and lots of interaction. So as we go through, just make a note of any questions that you have, or put them in the chat. So Terry Bryers, to introduce him, he is a builder who has been building his whole life. And he's been involved in Passive House in New Zealand for the last 16 years, which really makes him one of the front runners in New Zealand in the Passive House field. He now really wants to focus on only very high performance buildings and Passive House, and he thrives off the preciseness, which is definitely a trait of Passive House. So he was the builder in charge of the Piha retrofit project, which is still the only certified retrofit project in New Zealand. It was a very, very ambitious project, and is quite different to the project that we looked at last week, Matteo's timber frame house. This one is concrete block. So lots of different learnings involved in this one. So I will hand over to Terry, and I'm going to try and share his photos for him. So just give me a moment to get that set up, and then Terry, do you want to just start introducing yourself while I get that all set up?
Yeah, hi. So yeah, 16 years ago, I was introduced to Passive House through different ways, but the main thing was I was surfing on the web and I was looking at different building options, and I found this system and I thought, yes, great, this is me. And so we got stuck into it and went down that path and joined up with a group in New Zealand and worked with them for 10 years doing Passive House buildings. And then this particular client came along and said he wanted to renovate. He'd bought this existing building and said he wanted to renovate it, up-spec it, but not Passive House. And so there's photos, we'll go through it later, of some existing photos of this building, but it is a concrete block structure with concrete ground-based floor, and mid-floor was concrete with a timber-framed roof, flat roof. I think it was about 3 degrees, with a bitumen membrane. There it is there. So that's the existing building as it was when we arrived on site. So we started to strip this building out, and you'll see, if we go back to that last picture, Jessica, if possible, that there was no ventilation in the soffits. So you'll see there's no grills in under the soffit. So there was no airflow going through the roof of this building. And then we pulled all the ceiling linings out and found mold in all the framing. And then we started pulling the wall linings off. And these particular buildings, which is pretty common in New Zealand, block structure. You've got 20 mil strapping on the inside, which is timber that's fixed to the block walls. And then there's 20 mil of insulation, which is nowhere near enough. And so there was mold, because what happens is you've got the cold air penetrating into the building and you've got the warm air permeating out of the building. And at that point where they meet, we get condensation. And without airflow through those areas, the condensation stays there. It doesn't dissipate. And so what that does is it forms mold, and that mold becomes very toxic. And this particular owner was very, he had experience with moldy buildings, and he had a health issue with it. So he said, right, well, okay, what are we going to do? And I suggested to him, well, passive house anyway. So that's what we did. Luckily, he had the funds to move ahead with that system. And so we got in touch with a passive house architect, and also an energy specialist who was actually Jessica's group, Sustainable Engineering, so Jason Quinn. And Jason and I worked very closely together on this building because it was out of the box. Every day pretty much was mitigating factors. How are we going to do this? What should we do here? And so we worked our way through it and actually made it work. But very lucky that with my 10 years previous experience, I'd done a passive house tradesperson's course, which is really, really important if you want to do passive house building. You need to have foresight to understand why you're doing something, and how you are going to mitigate what you're going to do through your learnings. Very, very important to know exactly where you're going, or else you end up going one step forward and 3 steps backwards. What else? So this building, through Jason's expertise, we lined the outside of the blockwork with 100 mil graphite impregnated polystyrene. And you'll see here, so this is the 100 mil graphite being attached to the outside of the blockwork, and around the base of the building, because it was a concrete slab sitting on uninsulated exterior foundation work, Jason figured that we needed to insulate 600 mil down from the finished floor height of the inside of the building. So if we couldn't go down 600, we had to go down and out. So you'll see a little skirt of polystyrene protruding out around the base of the building. So we dug down to the foundations all the way around the building, and laid in a layer of polystyrene, and then the plasterers fitted a base skirt with a 45-degree angle on it, which was a capillary stop. So any moisture that traveled up got to that capillary stop and couldn't move up behind the cladding system. So the cladding system sat on top of that 45-degree angle. So that piece went around the building all the way around just to start with. And so that insulated the perimeter of the slab and insulated the exterior of the building. And so because this building had a timber roof, we had to airtight seal the timber structure to the wall blockwork. And so Jason decided that because the exterior blockwork was plastered and painted, that was going to be the airtight layer for the walls, and the roof had torch iron membrane, and that was going to be the airtight seal for the roof. So what we had to do was seal between the roof and the wall by means of taping. So where there were rafters that protruded out over the top plate out to the soffits, we had to put in plywood. We cut in plywood gussets, battened them all in, and then we taped around every joint. We used, I don't know, one of my guys was taping for 4 to 6 weeks. And you'll see this particular beam that's protruding out from the building. This is a steel beam. You can see the flange at the end where it bolts to the outer perimeter board. This was ply wrapped and taped, and then it was polystyrene wrapped, so that there was no, so we minimized the thermal bridging through the steel that continued onto the inside of the building. So Jason modeled all of these and told us what thickness of polystyrene we need to line all of these beams. There was quite a few of them protruding out, which supported the soffit which ran around the outside of the building. Huge job in taping for this building. And then because the roof had to be insulated as well, so over the top of the existing torch-on membrane, we had to re-pitch the roof to 3 degrees, and then 2 layers of 80mm insulation board were laid over the top of the 3-degree pitch, and then new torch-on membrane was fitted to that. So we basically had 100mm insulation on the walls right down to the foundations, 600mm down from finished floor height, and 160mm insulation over the existing roof. You'll see here these bits of plywood that are fitted between the rafters. This is where a window was sitting in this opening. So then we could tape down from the plywood onto the window when the window was fitted. Yeah, and the insulation was layered in between all of these. So we had a continuous layer of insulation up to the insulation on the roof above the plywood. What else have we got here? It just shows you all of the taping around the soffit areas. One particular problem we had with this building was the second floor had protruding concrete decks, and we were developing the underside of those decks into new rooms, and one of the rooms was an existing room. So to mitigate thermal bridging from the exposed concrete on the outside of the building through to the new ceiling with the new room below it, 80mm insulation board was glued to the underside of the concrete deck. And then Jason modeled that we needed to run 20mm insulation board down the walls from the ceiling wall junction down 600mm. So we did all of that. And then what we did was we put a suspended ceiling in those areas. And with the ventilation system, the return air was channeled to go back through the lowered ceiling area. So to make sure that the return air didn't make a direct line to the pickup point, we actually put baffles in the ceiling space. So at about 1 meter centers. So we put a baffle that glued up to the insulation board and came down and sat on the back side of the ceiling. And what we did was, we call them baffles. So one line of baffles had a gap in the middle of the length of the line, and then 1 meter back, the next line of baffles had a gap at each end of the line, and so forth. So what it did was it made the return air channel through the ceiling space that was actually, if there was going to be any moisture or whatever from the outside concrete finished deck, it would be, we had airflow flowing across that section area, so it would mitigate any moisture problems. There is a photograph there of it somewhere. that baffle line.
Terry, I'll see if I can find it.
Yeah, that's it there, yeah.
Okay.
So we've got the 80mm insulation board glued to the underside of the concrete above, and then we've got full-length baffles at meter centers. You can see quite clearly one baffle there that's got the gap in the middle. You probably can't see it that clearly, but the end of the next baffle in front of it, there's a gap at each end. So as the air flowed through that region, it had to dissipate through the whole ceiling space. The pickup point, you'll see the flow air ventilation in the back corner, just to the right-hand side. You'll see a little white square box there. Well, the return air is just to the right of that, up inside the ceiling space. So it actually, the air had to dissipate right across to there. A brilliant idea, and it worked really, really well. There was no problems with air flows. The other thing that we did with this building was the owner was he wanted to individualize each room. So each bedroom door had a seal right around the door. So when you closed the door, a seal dropped down from the underside of the door. So basically the room was sealed off. So we had flow and return lines to every room. So instead of having a flow to every room and a return from the bathroom or the toilet area or the kitchen, each room had two ducts. So in the plant room, which I haven't got a photograph of because it was too complicated, there was double the amount of ventilation pipes, and yeah, it was quite interesting in an existing building, getting all that ducting through the building. It was a case of having to think about your the lines of the ducting. So you can't have the ducting lines climbing over the top of each other. You've actually got to route. Think about the routing of each line and where it's coming from, where it's got to go to. So when you're coming through a confined area, all of your ducts are all in line and they all flow from that, where they're in a congested area, where they flow away from there. They don't climb over the top of each other, basically. So you've got to really think about where you are putting your ducting lines and how you're going to run them. The other thing with this building we found was product supply. This was really interesting. When we came to do the blower door testing, we found products that weren't performing, and interesting that they were sold as airtight products. For example, one of the duct lines, so it was supply air and return air for the hood range. So we had a supply coming through the floor and under the bench that permeated above the kicker. The kicker had a gap in it, and it came up and flowed over the top of the oven to the pickup above it and then out through the wall. Well, these, when you switch the ventilation system on, the extractor system, there was a damper inside the ducting. So you bought a tube with a damper in it. So when you turned it on, the damper would close, and when you turned it off, the damper would open, or vice versa. But I found when I did my blower door test that the pivot pins on the damper and then the waffles that did the air tightness, there was a gap between the pivot pins and the seal, the waffle seal, of about 15-20 mil on each side of the pivot pin. So you don't really think to look in there and test these things before you actually install them. It wasn't until we did the blower door test that we realized that it was leaking. So it's actually really important to just check all of your componentry, before you install, to make sure that they are actually airtight, because when it comes to doing your blower door test, especially come certification, if you can't get certification because you've got a leak in a product, then you've got to pull it all out, it can be an absolute mission plus a big expense. So there are some photos here of the finished product. If you can find those,
Yep.
Jessica.
Bear with me.
So
Okay.
yeah, so that's the existing build.
Do you want me to just scroll through them?
Yeah, you might as well, yeah. So this product, so the owners were very, so their business was herbal products. So they were right into natural, non-toxic products. I don't know whether any of you have come across this product here, but this stuff is brilliant. It says here, an indelible. I actually thought that said edible. It smells so good, you could mistake that for edible. This product, you paint the whole exterior of, say, a timber bench. The bench is waterproof. It keeps its color. It doesn't fade. This product is absolutely amazing. It actually smells like honey. It smells like you could put it on a piece of toast. It's not cheap, but man, this stuff is so good. Non-toxic, water repellent, everything. So anyway, so these guys were very natural product driven, to the extreme in a few cases, but all good. So all the interior linings were wood. So this product was on all the walls. So this is plywood from Austria. It's oh, I forget what it's called. So what the painter did was he wet the sheet and then rubbed it off with a rag and then put the first coat of stain on it. What happened was when the veneer got wet, it pronounced all of the grain. And then when the stain went over, so there was like 4 coats of stain went over it, and then they started doing the finishing ceilings on it. But this is what the ply looks like up close. From a distance, it's not that pronounced, but it, it's it's a beautiful, really, really nice finish. You look at a lot of timber work and you can see knots, but this was another thing. It was amazing. So there was basically all the walls were plied. Some of them were done with the Osmo, that product I just showed you, which was basically a clear finish. And then there was this dark brown finish. Um, all the floors were oak, all the doors were oak, all the ceilings were cedar, all the decks were timber, all the ceilings and the floors and the decks, all the grains, all the links ran the same way. So we had a continuation line, ceiling, floor, and decks. Everything ran the same way. Instead of having, bits of wood going in different directions. The plywood, what we do was, because the joinery had a 4 mil quirk margin between the sash and the frame, all of the wall boards, all the joins, we had a 4 mil quirk margin for every join. You can see it over on the left-hand column. You'll see a line at 2.4 around. So that join ran right around. It's a bit hard to see, but I don't know whether any of you have ever put plywood up. It's never perfectly square. And so to actually get a line running horizontal, as well as having all your vertical lines meeting up, is quite tricky. So we have to run a level line basically right around the building and then work down from that and up from that. But you can see it is a beautiful finish inside the building with all wood. Yeah. So yeah, so that was when we did the blower door test. So this building we just scraped in with with the maximum that we were allowed for the EnerPHit, which was we had 1.03 at 50 pascals, which was so 1.499 is the max. So we made it, and huge challenge, but yeah, we got there. So I think that's it.
Awesome, really beautiful project, Terry. It's quite stunning and very, very unique. So well done. I can tell it was a huge undertaking, but beautiful result. I've got lots of questions, but I think we'll just keep going with the speakers, and then we'll just do all the questions at the end. Matteo, if you would like to jump in, I'll just remind those of you who were here at the last session, and for those of you who weren't there, introduce you to Matteo Garbagnati. He is an architect and builder, and also a passive house designer, and his partner Gabriella have set up a COP studio in Wairoa. They're the only architects in Wairoa. And this project, the Wairoa RetroPHit, is his own house. So he was in the extraordinary position of being architect, builder, passive house designer, and client. So some very unique insights from him. So I believe that Matteo is going to give us a bit of a summary of the project from what the extended version is what was presented last time. So go for it, Matteo.
Yeah, thank you. Shall I share my presentation?
Yes.
Yeah, can you see? Does it show up?
Yep, perfect.
Yeah, thanks, Jessica. Yeah, very different project, very much more humble. It's great to see what Terry had to do. Very interesting project. Yeah, this one definitely much more humble, and probably I would say easier. So what we have been dealing with is still ongoing. A single detached house in Wairoa town. That's view from the top. When we picked it up, that's what we found. Yeah, very rundown. The house is from 1950, timber framed on some kind of concrete floor, single story, but with a quite a lot of volume in the roof. And yeah, that's the roof volume. So immediately we thought, well, we should use that volume to do something with it, make a double high space, mezzanine or something. And there were other features, and also the layout in general was kind of suited us. So we thought with minimal changes we could make it work. And yeah, well, then there were the usual surprises when you get an old house, the usual bit of rot, a bit of bore here and there, some asbestos. But anyway, the other tricky thing for us was the budget. So we want to do a good design, affordable, and yeah, we are in the little green zone. Even doing the EnerPHit certification can be a bit of a challenge. But so that's our existing and proposed. We kept the house very well. We basically kept it as it was, just done some minor internal alterations and upgraded the envelope substantially, and then built a new outbuilding at the front. And that's the existing plan so you see very minimal changes. 3 bedrooms, open living, lounge, and mezzanine, which we added. So we basically reclaimed all the volume in the roof space. remove the ceiling in the living area, open it up, put a mezzanine in, change all the roof structure, and most of the space in the living area is open, so it's all kind of living space. And then in the lower part of the roof there is a bit of storage space, sort of an attic. And yeah, that's how, space-wise looks. Just to give you a bit of a feel, or that's actually a bit more indicative when we started demolishing. So that's what we were dealing with. In terms of the upgrades, we followed the kind of the well-known strategy of building a passive house, and we applied it to the retrofit. So we upgraded all the walls, all the roofs, all the roofs, new doors and windows. We insulated the floor, retrofitting insulation on top of it, and retrofitting the airtight membrane, and then mechanical ventilation with heat recovery, and a more efficient, an efficient hot water system. Wall construction, again, so borrowing from the knowledge of how to build a passive house, we insulated the existing cavity, 90 mil framing, thereabout, maybe 100, and then added a service cavity with the airtight membrane in between. And we retrofitted, we had two wall claddings. One is weatherboards, timber weatherboards, and one was stucco. On the stucco one, we also added a metal cladding in front with a ventilated, with a drain cavity. While where we have the weatherboards, we also retrofitted a mesh, polypropylene mesh, to create a bit of airspace, because otherwise it will be just the usual direct fix. And you see here, while this is in the process, so the studs have been painstakingly removed one by one. In some areas, most of the areas I left the cladding on, and I removed couple of studs at a time, replace and carry on, so that the weatherboards didn't have to be touched or removed too much. Again, in order to preserve what we had there and minimize the work, and also fitting with my work schedule. Sometimes, it was just a couple of hours a day. So I didn't want to have the house open completely on one side. Then yeah, you see retrofitting we have used Intello for airtight membrane, and that's the front of the facade with front of the building with where we retrofitted. We added also a metal cladding. For the roof, similarly, so we changed clearly all the insulation system, because before it was flat ceiling and insulation, some insulation on top of it. And we made it so skillion, so insulation between the rafters, retrofitted airtight membrane, and then a service cavity. Different thicknesses, because one area had strengthened, new rafters where we had the mezzanine in this area. So we changed the rafters. In the rest of the roof, we kept the original rafters. And this is in the process. And retrofitting the mezzanine beam was a bit of a challenge, probably nothing compared to what Terry had to do, but yeah, I found it quite interesting to think about it. Removing the existing ridge board and slotting in a new ridge beam. And yeah, that's in, and it was great to do it. So then, in terms of exterior openings, we have one skylight, and that adds a great addition for the mezzanine. Can create a bit of overheating in summer, but that's a bit of a trade-off. We managed to use a Velux triple glazed, and I know it's a bit tricky to make it work in other climate zone, but in our climate zone, you can still make it work if you pack all around the skylight with some kind of rigid insulation. For windows and doors, we use triple glazed timber with aluminium skin outside, and they are from Europe, as very often we have to. They are, well, yeah, they're good windows. They're not probably this top performance, but we are in a warm climate zone, so they work fine. For the floor, again, so we have concrete. There is a concrete floor. It's not really a slab. It's just 60, 70 mil thick, unreinforced. So we are going to add rigid insulation on top, EPS foam 30 mil, and then floating engineer floor, timber floor on top, again, to keep the thickness, the build up to a minimum. And we chose this option instead of insulating outside because, well, it was be more challenging to insulate outside on along the footing. And I've done a modeling in therm first, and yeah, the results with internal insulation was probably better, and it seemed a little bit easier to retrofit. For the airtight layer, again, I thought this was challenging, but after seeing Terry's job, this is a bit of a joke, almost. But yeah, our challenge was retrofitting the membrane, the Intello, and going through all the existing ceiling joists. You just deal basically with very tight spaces, but otherwise the task is tape around it, and that's it. So done it in sections. So going from the front, from the top first, and then cut a slot in the ceiling, 50 mil in the gap, 50 mil slot in the existing ceiling, and then join the Intello from the wall to the roof one later on with the usual tape. And yeah, I don't have a photo, but you can see here there is also I've cut all the internal walls another 50 mil, so I cut them back from the external wall so I could also fit the Intello continuously. So to create to maintain the membrane as continuous as possible. And where we have the mezzanine new joists, we put the Intello first as per good construction for a new passive house. Services, again, that's how I'm pretty sure everybody is quite familiar with this. Nothing extraordinary, just sealing properly all the penetrations as best as possible. And then, yeah, we've done a quality assurance pressure test, and that was good. I was not expecting such a result. It's 0.45 air changes per hour, so it's great. Maybe we can even improve it, because after that I found a couple of areas where I didn't tape properly. So, but yeah, if we can keep that would be great. And our services, we managed to reclaim some space in the roof space. This is extremely tight, but it works, and it's great to have it. What we've done here is in order to fit both the mechanical ventilation unit and the hot water storage, I have lowered the ceiling and make it all waterproof with a membrane. So if basically it's all like a sort of a large drip tray, and there is an outlet that discharges on top of the bathtub. And so if it leaks, it goes straight into the bathtub, and you can see it. Mechanical, well, yeah, services with all that tight space between mezzanine and, well, a ceiling and roof. We had plenty of space to fit all the services, which was very useful. And we have some space heating, and we opted to use this EcoDan, the Mitsubishi EcoDan system that can do both hot water and space heating. And we have two radiators, it's a heated towel rail in the bathroom, and one is another vertical radiator like this. Total heating demand was 1.2 kilowatt, as far as I remember. So yeah, relatively low. And PHPBN metrics, we're doing an EnerPHit by component. So the heating demand is not really there is no minimum to meet. There is more. It's more these next component characteristics, these values to meet them, or to stay below the minimum. And even in this climate zone, even if you use triple glazed timber framed windows and doors, it's still pretty tight to get to satisfy the standard. Other than that, yeah, walls, roof, it's much easier. So just retrofitting insulation and doing the well-known construction for a passive house, you stay well below the minimum requirement. Yeah, overall, so the existing house would have been using 216 kilowatt hour per square meter per annum, and the retrofitted finished, we are down at 27, so it's about 90% less. But we know it means also, yeah, not just very low energy, but also much more comfortable general house, drier, nicer, more healthy spaces in general. And that's how it looks pretty much now. So we are pretty much finished with lining. I'm in the process of doing all this gyps topping, while outside has been like this for maybe 1 year at least. I would say it's more, we're kind of doing a sort of a sleeper, so an unassuming house that outside you wouldn't, it looks okay, repainted and everything, but you wouldn't assume that it has such that the envelope has been improved so much, so dramatically. Yeah, that's it.
Thank you for that, Matteo. I love the contrast between the new blue cladding and the rusty galv iron on your shed. That looks really cool. I didn't see that last time. That's awesome. Yeah, just as impressive to see it a second time round and pick up things that I missed the first time. So that's very cool. We'll jump on to John now, and then we'll have mix up all the questions at the end. So John is the Tech and Education Manager at ProClima. That's where you would most likely know him from, but he is also the Managing Director at PHINZ, which is what he will be telling us about today. So PHINZ is a retrofit wall exterior insulation system that has many advantages that he'll talk about, and has its origins in social housing. But I will let John continue explaining what it is, and we will ask some questions at the end.
Awesome. Thanks, Jessica. Firstly, thanks for the invite to come and share a couple of different projects actually, and not so much one case study, but the process of getting to hopefully many projects. So it's been great to see Terry's project. That's very similar in principle to what I'm going to show you, and then it's kind of this pushback against this typical way we've always renovated. So I'll explain a few of those bits. I think, Matteo, I take my hat off to you. I have renovated in the way that you are renovating now. Oh, who's got the, oh, Jessica.
That's me, sorry.
You've got a fire station real close. So yeah, I've renovated, the last time I renovated was a 1970 brick and tile unit. The brick stayed on, I worked from the inside, linings off, wall underlay, it's a labor of love, absolute labor of love to do that. So I totally understand it, take my hat off to you. It's a predictable outcome in the speed but not always predictable with what you find in the walls. So you found wasps' nests, or beehives, whatever was going on in there. You found some other things too. That's what I'm going to describe as this is a bit of a different way of approaching the same need. So Parker wrap. What is Parker wrap? What is a Parker, first of all? A parka is an Inuit word for a jacket, which is actually an insulated jacket. I think typically in New Zealand, we've often referred to a parka as just a shell, but it's actually insulated. There's lots of similarities with what I'm going to describe with how we build and how we should be building, and how we have built and how we could renovate. So typically, our walls look like this on the left. So they are timber weatherboard to the left-hand side. They have no insulation in the walls, and they have plasterboard lining to the inside, single glazed windows. That's our walls. That's around about 720,000 walls in rented buildings look like that. We can also work out, not my data that is just easily found, Beacon Pathways work, MB's work. There are about 1.5 million homes in New Zealand out of about 1.9 million that have no insulation in the walls. So we should do something about that, right? That was the target of my research. It was a Master of Architecture research. It turned into something a little bit bigger than I anticipated as we went through it. So what is Parker wrap? Parker wrap is this idea that we can leave the occupants of the building inside the building and work on the outside from the outside. So this image, it's actually in our workshop here at ProClimate, just finished. Well, the cladding is semi-finished, but when I say that, it's supposed to be exposed and show the process. So what have we got? Bottom right-hand corner, there are old dirty weatherboards in there. They are, for the most part, left on the building. There's an investigation to check what is in behind those weatherboards. A weatherboard at the sill of every window would come out or come off so that we can check the integrity of that framing. The black piece there, where there's a weatherboard missing, is deliberate because that is the idea that you would take a weatherboard off, check the frame, but the weatherboard doesn't need to go back on. When you know that you've got a good substrate, you know you've got good framing, you know your foundations are adequate, then the blue layer goes on. So window out, replacement window, but blue layer goes on. So that's the ProClimate Ad Hero. I chose the ProClimate Ad Hero when I wasn't working for ProClimate. I chose it because it's a good product and it fitted what I needed it to do. Weathertight, actually airtight. It becomes the airtight layer for this type of construction. And then the window gets installed, the blue layer gets connected to the window, so you've got a continuity of air tightness and weather tightness. And then there's a framing system which starts to be put on at that stage, and I'll explain that a little bit more. But the rock wall becomes this insulating blanket, just like the parka, just like putting on a puffer jacket. The idea is the rock wall becomes this continuous layer of connected insulation right across the building envelope on the outside of the existing frame. Cladding on top of that, there's not a lot else to talk about in that image except for the process is all visual. So if you can imagine the quality assurance for this, the question is asked, is all of the wall blue? Yes or no? Is all of the window surrounds, all four sides, is that connected? And we use tape to the inside of that window, and it's exactly what Terry was showing in his images before. I think exactly what Matteo was showing as well. When you look at the inside of that window, you'll see that it'll be taped all four sides to the inside. And then on the outside, is it taped all three sides, or sorry, three sides, being head and jambs to ensure we've got a water shedding layer around the window. Then the next part, this QA piece, is put the rock wall on the wall. Is all of the blue covered up? If all of the blue layer is not covered up, you haven't finished yet. That's the level of continuity that we can create across the wall with the rock wall. So why do all of this? So in the research, what I took an existing passive house that was in design. It was in Rotorua. If you're interested in the numbers, it was going to be a certified passive house. It's still sitting as design. It hasn't been built. It sort of was a bit of a COVID stall. But passive house in this image is that little blue bottom right hand corner. And what I'm trying to do is show that the energy consumption of several different versions of that same house. So the biggest blue portion there on the left hand side is no insulation anywhere in that building. So single glazed timber window, but single glazing, and no insulation anywhere, which is still quite typical, unfortunately, of a lot of homes that are owner occupied. So there are hundreds of thousands of homes that have no insulation anywhere. So that 720,000 number that I used before, it's either that or 830,000, depending on who you talk to and what data you're looking at. So that's a completely uninsulated home in Rotorua, and that number in kilowatt hours is 486. So if you tried to heat that building, which was a 200 square meter floor area over 2 floors, that would to heat that building to 20 degrees, that would consume 486 kilowatts of energy, compared to the passive house, bottom right hand corner, 15. So what I did was I took that model and I said, well, if it's compliant tenanted, which is the light blue bigger box there, that would mean that it has insulation in the ceiling and underfloor. So I used, changed the values in the spreadsheet and said insulated ceiling and floor, but otherwise nothing, nothing else done. You don't need to do anything else. That still required 186 kilowatts of energy to keep that building at 20 degrees year round. So the difference then between that light blue and green, which is the Parker version of this, is only wrapping around the walls. So no change to the ceiling of that compliant tenanted building, no change to the floor, just putting Parker around the walls. I left timber as the frame and put double glazing, so glacier glass, and that came down to 67 kilowatts, I think 68 kilowatts of energy to keep that building at 20 degrees. So that's a really big shift. That was enough information for most people, I'm sure. But what I'm showing there is if you insulate, and that was only with 75 mil of insulation of rock wool around the outside of the building. So just so it's super clear, not trying to target passive house or EnerPHit at that. This is just a comparison of what you can do with different levels of insulation around the outside of the building. And it was always aimed at social housing. So just going back a bit of a step now, during the research, so I was actually the lab manager at this test facility in Avondale. I had access to the test booth that we were building. I built a replica 1940s wall. There it is. Yes, it's got pink timber, but the key bits with the wall were the reaming weatherboards, the timber window. I put that into our test rig and used all of the testing that we could do. It was COVID time. We had no clients. I had hours and hours of opportunity to throw water and wind pressure at that building and seismic movement as well. That wall got absolutely thrashed in all directions. Weatherboards work really well, but they leak. And if your wall, if we think back to that first image of that uninsulated timber wall, weatherboards can leak, but they dry out. They drain and they dry out quite quickly. If you stuff them full of insulation, the walls, you slow down that drying process. So that's why in Matteo's presentation, that black mesh that he talked about against the weatherboard becomes really important with a weather tightness layer in behind that. So that provides drying and it provides drainage back out away from the building. So I got to test this, and then on the right-hand image there, that's now inside the booth, but this is with the Parker wrap system partly installed, but then I've taken a lot of the cladding off. So I was seeing what would happen to the rock wall if you fill it full of water, and it gets wet and it dries really quickly, or it drains really quickly before it dries. I'm going to keep going. I'm just looking at the time with about 4 minutes to go before our Q&A, so I'm going to keep racing through. From the research, we then started to realize that it wasn't just about social housing, it was a whole lot bigger than that. And so a business partner and I started a little business to create the components. So we don't own Rockwool, we don't own Proclaimer products, we use the Stark windows for our projects, the UPVC. We don't own any of that, but we do own some little products which bridge the gap from the existing to the new cladding. And so this is called a banana bracket. It has other root names that sometimes get used, but we call it the banana bracket. It's hinged at the existing wall side so that it will cope with more or less insulation depending on requirements, depending on climate, depending on modeling that will show you how much you need. As soon as you put as soon as you put 2 screws, and on the left-hand side of that diagram there on the left, it locks the batten up and it cannot move. So what does it look like in a detail? Joe Lythe drew this one for us for our first project with an education provider out by the airport. And this shows the position of the window, and I'm hoping, no, my next image doesn't show that. Okay, so position of the window is outside the structural line of the existing building. It is in contact with the rock wall. So if you want to make your window perform really well, line it up with the insulation. That's what we're able to do with the system. And you think, well, how does it stay up? Well, that is a good question. I'm going to show you that in a second. But just before we go on, the banana bracket there is sitting on the angle of the weatherboard. It could be sitting right back against the frame if the weatherboard had been removed, but it's sitting on the angle. It could be applied to a block wall. We've put it onto a fibre cement weatherboard project so far. Got a stucco wall project coming up, which is my own house. So lots of different options there and flexibility of the depth of insulation. So that detail in action, kind of, because you can't see the base of the window, but this is with the banana brackets. They get put onto the wall, connected to the framing, and then the rock wall is pushed over the top of those and then mostly pinned down with the vertical battens. This is another little invention, kind of pretty happy with this. I think this is going to be the most lucrative part of what we have created, but these look a little bit different now because they've been actually put into production rather than just being cut out of blocks of acetyl delrin. But that window cam, you'll see the one on the left there, they all have an offset fixing point through that cylinder, which means that you fix one to the frame and roll it for the height that you want, and then you get your next one, roll that for the height with the level across that. So you can imagine that gives you the ability to level up your window. Those get locked off. There's another little light screw, which pins that now. And I do think that that's Joe Lythe's arm there on the right. You better confirm that maybe in the Q&A. So that is the position now of the window sitting on those window cams. So that blue rectangle there is the window cam. It's not a solid bracket all the way through. Again, Stark windows, they work really well. Yes, the data is there for Passive House, dropping that into the Passive House planning package as well. It's not unusual. It's now sort of common practice pretty much with the way that you would typically use outright continuous insulation. And it's 5 o'clock. Jessica, shall I stop there? We should stop there, eh? Okay, I'll race through because I've only got a couple of slides left, I think. Only 18 slides left. That's a little joke.
You can have 2.
Okay, cool. 2 slides, 2 minutes. Okay, let me go fast. All of the work that we have done, the banana brackets, the window cams that are on the screen here, they've all been engineered. We know what it will cope with. We're looking at a maximum of 25 kilograms per square meter of cladding weight. The window cams themselves are plenty. enough. If they can cope with my massive bulk, with me standing on that, they can cope with a window. You put more on if you need more. The engineering has been done by Oculus Architectural Engineering. The testing that we did was at Shelby Wright Test Labs. This is now after I left Oculus and Shelby Wright, where I was the lab manager. So it's all legit. We destroyed brackets. We actually broke the rig and the plates that were holding the sample into the rig before we broke. So that one broke the rig at 770 kilograms of pull force. So we know it's robust. We know we've got a reasonably good system. So going back to the house that Joe designed, Joe turned up to this building. It's at the ARA Education Charitable Trust at Mangere on airport land there. Students come in, work on the buildings. Students didn't work on this building. We had slightly higher skill level used for this one, but not German master carpenter level. So this is everything that we've just talked about being put together. We left that corner of the building that's facing us, or that we're closest to, we left that exposed. So it's a little bit unusual that you would leave blue, the weatherboard's exposed, but blue layer on, banana brackets on, window replaced, taped in, rock wool on, steel battens over the top of that, and cladding over the top, and that's job done. I think that's about it. That was my 2 minutes, and it's now 5:03. I'll stop.
Wonderful, thank you, John. That was really, really fascinating. I have a bunch of questions, but I would love to just open it up to the floor first. Okay, there's a question from Richard. Richard says, what options for connection of Parker wrap to ceiling roof insulation?
Great question. I should have just pulled up the detail. I've probably got that detail in the presentation. No, I don't. That's a great question. So what we did with this project is, and like projects, we deliberately chose out of 5 houses a house that had a concrete tile roof. So we were able to push concrete tiles out of the way at that soffit area and work from the top. So going back a little step, there was no asbestos in this building. It was an ex-Kaingaora home. When that was gifted to the charitable trust, it was checked for asbestos, no asbestos, but we treated the soffit as if it was, which meant that we didn't want to touch it. We didn't need to touch it, and so we pincered, if you like, the blue layer and the insulation layer around the soffit line. So that blue and that insulation then rolls up over the top plate and connects into the insulation in the ceiling. And I'm deliberately saying not the airtightness layer. The plasterboard on the inside of that building on the ceiling is technically the airtightness layer. It's not an awesome airtightness layer, but our work was at the outside on the vertical portion of the wall. And if you just think that through, what we did at the base of the wall is we came up around the perimeter and connected back to the floor again. So in this case, it was a strand board floor. So then that floor is our airtightness layer. Again, not incredible, but again, this was about what can we do simply to, I bet that's the detail coming from Joe. Is that right? He's just put that in the bottom of the chat. There it is.
Yeah,
Does
that's
that help?
all. Yep.
If you just pick that up and click on that, that'll enlarge on your own screen, I think. We're not sharing, are we?
I can download it and then put it up.
Anyway, I think the guts of that is, yeah, we pinch it around the soffit. Hopefully, Richard, that's enough of that explanation.
Shall I just quickly bring that up?
Yeah, if you like to. Yep. So I guess the consequence of us
sorry, lost it.
no, that's right. The consequence of using plasterboard as our airtightness Okay, so let me explain that. So right-hand side is outside, concrete tiles at the top right-hand corner. Blue layer coming up the wall is the adhero, and it doesn't perfectly follow the weatherboards like that. It doesn't need to. So that's a peel and stick layer, which is on the wall, and that is then taped off, or could be a bead of Orcon glue to connect that positively to the soffit. Then the green line above is that continuity of the airtight layer. And I said that we pincered with adhero. We didn't. We actually used the spray and Viscon product from ProClimber to get into that space, which was dirty and dusty. And instead of cleaning all of that out, we basically just glued a bit of that dirt and dust. We took away insulation. All of the insulation was removed. So we sprayed into that space where the green layer is before the insulation went on. What do you think, Joe? Is that enough info?
That'll do.
Yeah, so just last comment on that then, which we used the floor, the strand wood floor, which wasn't in awesome condition, and the plasterboard ceiling as that sort of top and bottom, the continuity of our airtightness layer. So the walls were great. The walls were airtight. That blue layer connected to the windows is easy to seal together. It's great, but the floor and the ceiling weren't great. And so we probably either just acknowledge that that is not going to be incredibly airtight as a building, unless there's a whole lot more work done top and bottom to that, which go back to what Terry showed us, that's the level of detail. If you're trying to get to EnerPHit, you would be treating that a little bit differently.
Cool. Okay, and let's get through some of these. So Joe says to Matteo, did you consider PIR on the floor rather than APS? And did you consider external insulation rather than working from the interior?
Yeah, well, sorry, maybe I said something. We are using XPS on the floor. Yeah, I did consider PIR. Initially was my first option. We went for XPS because the XPS offers more compressive strength, like about maybe 3 times the one of PIR, thereabout. And cost-wise was also on the more affordable side. So yeah, we went with that. And external insulation, yeah, I did consider it. And that's it. I only considered it. I didn't do it. I really like this Piha wrap system. But yeah, in our case, for instance, it wouldn't really have been applicable because the framing in too many areas was just far gone. Yeah, but yeah, if you're guessing, if you had the framing perfectly fine, yeah, that's a great system.
Matteo, you had a question for John.
Yes, yeah. How many of these Piha wraps have you done, and with occupants in, and you were in, what did they think? What did they?
Yeah, great question. So the answer is we are up to about 3, maybe 4 in design at the moment. That would be generous. So we're right at the beginning. We've just landed product ready to actually sell into the market to achieve this. But otherwise, my house is one of the next ones that'll be worked on. We've got some discussions, loose discussions, to be fair, with the Ministry of Defence for their building stock in both Whenuapai and Ruapehu. What am I looking for? You know what I'm looking for? Aokuni? No, where's the base? I just lost them. Anyway, Ian knows. Ian's trying to unmute himself. I can see it.
Waiuru.
Waiuru, thank you.
Waiuru, yeah.
Oh, yeah. Killing myself. Yeah, so we are super early. So one finished, and that house that I showed is completely finished now as a shell, and needs kitchen and bathroom, and it's also on the market. If somebody wants that, Richard, you're just itching to buy it. I could see it.
Thank
While
you.
you're in the
Yeah.
spotlight,
I'm a
while
bit
you're
of
in the
a South
spotlight,
Island
John.
boy, sorry, so it's probably not for me.
Just sticking with you for a moment, John, are there any types of buildings, any construction systems that you wouldn't recommend your
Yep.
system on?
Yep, it's not a fix for a leaking building. I think what Matteo's just saying, I'm not suggesting your building was leaking. It's certainly been leaking, right? If it's damaged, it's not a fix. It's not a wrap up and hide. That's one. Two, it's not a system for going over eaves, so a externally insulated finishing system. So those banana brackets, they're just going to crush a polystyrene foam board on the outside. And thirdly, it's not for brick. I had hoped that we'd be able just to start fixing directly to brick and wrap up those buildings that have a block base. Great for block, by the way, just saying. But when you get to the brick, where the brick runs straight on vertically with the block, I thought, great, we can just carry on. But you can't pin to block. You can't rely on the brick tie and the quality of that fixing. It's just don't go there. So you better to take the brick off, skin from the outside, skin the block. Yeah, I think that's about it as far as what you shouldn't do with it. I think.
Just
Well,
on that,
no.
I've got something to share, if I may. I'm working on a project in Blenheim at the moment where they did exactly that. It was an old home, 1950s villa with brick on the outside. They took brick off and they actually chose a SIPS panel on the outside with a new foundation wall that's fully insulated and dug deep. And so that covered their floor slab. So I just thought I'd share that.
Was Meredith connected to that one? Is it? Yeah.
Yep, Meredith. I'm working with Meredith. We're doing all the mechanical stuff.
Just
Nice.
worth it as well, John. Insulated buildings, if the wall's already insulated, being mindful of the amount of insulation in the existing frame before you start putting more on the outside and things.
Yeah, so that's a really hard one because if the building is insulated, let's say the building was insulated in the 80s, I would relatively confidently put park wrap over the top and not worry about what's in the wall, unless you've got beehives like Matteo did. But the amount of insulation in there is going to be, I don't know what you want to call it, pathetic. You know, slump to the bottom of the cavity. It's not going to affect. So it's just about understanding dew point or temperatures within the wall, and not, you know, we've wrapped up buildings in the past with polystyrene and made them rot. You know, the quickest way to rot a building is just to wrap it in plastic, or rot timber at least is to wrap it in plastic. So we've got to understand what the vapor movement is going to be through a wall. Putting the parker wrap on an uninsulated wall is quite safe. We can confidently say that. Putting it on an insulated wall or a mix of insulation, that's where it's worth checking carefully what will actually occur with temperature and moisture movement through that wall.
Would you always do that modelling if there was some insulation present in the cavity? And is there any other scenario where you would do the modelling, the hygrothermal modelling, even if there wasn't insulation in the cavity?
If I knew there was no insulation in the cavity, because of the layers, we're putting on a vapor open blue product, that sticky one, which is also the airtight layer. So you could call it a vapor control and airtight layer, but the insulation is all outside that, and there's no other layers that will get in the way of moisture. So if you think back to that image that I showed of the water being sprayed in the test booth, that was with no cladding, filled up the insulation, but the wall behind it stayed dry. So even if you had water, even if you had stupid amounts of condensation forming in the insulation line, that insulation is free draining and it's already outside the building envelope or the drainage line of the building envelope. I believe that's, so I wouldn't, yeah, it sounds a little bit careless, but I don't think it is. I wouldn't bother modeling, hygrothermally modeling a build-up with that when I knew that there was no insulation. wouldn't need to do it if it was a block wall, wouldn't need to do it if it was a timber wall, uninsulated, maybe other construction types. Sure.
And Matteo's asking, do you have an indicative dollars per square meter figure for the system?
That's a tough one. We've got the engineering judgment or a slightly slimmed down version is available on our website, which is parkerap.com. In that you'll see the span tables, and so it's really just a case of knowing what the wind load is, knowing what your cladding load is, and then you know, it's a bit of a tough one. You know, what cost of cladding? Ian's shaking his head, no, nodding, saying, yeah, it's a tough one to put a dollar figure. What I do know, what we worked out quite quickly when I was doing some of this work with Joe, now almost 3 years ago, we do know that the cost of decanting, which is the word that is used for decanting people, not just wine, but if you decant a family out of their home, and this is what our comparison was with cost, if you decant a family out of the home, Kāinga Ora at the time were spending about $330,000 for the renovation, which included the decanting and the housing of the family for 4 to 6 months, and then bringing them back into the home. And yes, they got a new kitchen and bathroom, and that's good, and they got a better home. But if you take out that cost, then you know, if it costs, I think I can give you an indication, not maybe of a meter rate, but for that 80 square meter home that we did out of the airport, we work out approximately $135,000 to do that work, and that includes the windows, and it includes the ventilation system, which is a Stiebel Eltron balanced pressure mechanical ventilation system.
Wow, cool. And would you always install a ventilation system with your system?
Always. For my project that I've started, ventilation system went in first, and that's a 1939 Art Deco misery box, currently running 18.2 air changes per hour on the blower door test. 18.2.
Good score. Awesome. We'll leave you alone for a moment, John, because
okay,
there are some questions for Terry and Matteo. So, Terry, what was in the same vein? What was the approximate construction cost per square meter of the Piha house?
Well, yeah, that was very, very expensive. He was very driven on what he wanted, not really on what it was costing. I think we were somewhere between 10 and 13,000 a square meter.
Yeah. And John asks, do you think that retrofitting was the best option for that house if you'd been the client?
Yes, I think to pull it down and to redo it again, yeah, would have been expensive. Plus nowadays, you know, as well as passive house, we're now looking at carbon introduction into the building products. So to actually retrofit an existing building with all that embodied carbon, you know, it makes sense. A concrete structure like that makes good sense to renovate. It's a good solid structure. There would have been cheaper ways to do it. You know, the expense that was spent on the inside of that building was phenomenal. Like individualizing every room, and yeah, just lots of things that didn't need to be done. So it could have been done a lot cheaper than that. So, you know, in that mindset, definitely, I think the renovation is a good way to go.
And that follows on to my next question, actually. What was the reasoning behind having a supply and return to every room?
Because the doors were sealed, that meant there was no flow from the room to an extraction point in another room, which is how it's normally done. So the extraction point would be in a wet area or a smelly area or a heat providing area. because the doors were completely sealed, that individualized that room from every other part of the house. So we had to have a flow and return in every room.
And the sealing of the doors, was that for acoustic reasons?
Yes, yes. Soundproofing, yeah.
Mm-hmm. Mm-hmm. Joe asks, where it that was spent on the performance rather than the interior that you just mentioned being very high spec. What proportion of it could you attribute just to the performance related aspects?
Oh, Jingos, I'd say probably a third to 2/3. Inside, I mean, those sheets of plywood to get that look, that plywood was imported from Austria for starters, and the process of getting that finish. So the stain could only be bought by the 1 litre tin, and I think it was like over $100 for one tin of stain. And there was multiple tins of stain bought, plus then the finishing coats going over it. Then we had to cut them down. So the labor, I estimated it around about $600 a sheet by the time it was fitted to the wall. And we had about 120 sheets of plywood. So yeah, it added up pretty quickly.
Yeah.
But it looks amazing. So
It does look amazing.
Absolutely beautiful. And just to be inside it, the feeling of just all wood done in different colors. Yeah, it was really exceptional build inside.
The acoustics are good too, Terry, aren't they? Like
Were
acoustics
absolutely.
inside are amazing. It's a real
Richard
soft
worked on it
feel.
with me. He was pretty involved in the build.
I can tell you that the mechanical ventilation was twice the price of a normal house because of the flow and return in every room, and sometimes twice that in every room.
Yeah.
And also because there was a serious moisture issue that Jason pointed out.
Yeah.
We had to really look hard at making sure that the ventilation was going to cut it. So it's pretty involved.
Yeah.
And the client was quite insistent on having it look and feel a certain way, which is what Terry is alluding to. A lot of the cost is aesthetics, not in performance.
For example, an interior door, these were solid oak doors and oak frames. So all the fixings were plugged like on a boat deck. So all the joinery was plugged. So, the intricacy in the finishing was intense. It was really, really awesome to work on. Probably once in a lifetime, really. But yeah, that's where the cost goes. Absolutely.
Matteo just asked, how was the plywood fixed?
So we use an RT silicon, and it was fixed with 40mm galvanized nails. So they were punched 3mm in from the surface, and they were actually a feature. So every nail had to be marked. So everything lined up. So all the spacings were perfectly even. Yeah.
Gosh, yeah. Any other major takeaways from that project, Terry?
That project has given so much actually since it was built. Just the interest in it has been phenomenal actually. Yeah, apart from that, it was a really good learning curve actually.
It's an amazing view from that house, I might say.
Yeah. Yeah.
Are there
looking straight at Lion Rock in Piha Bay. It's awesome.
Stunning. Are there any words of wisdom, Terry, that you would impart to somebody embarking on a ambitious retrofit?
Well, you need an experienced builder. The builder needs to have a blower door tester. I think you need to understand product, and you need to be able to test the product to see that it's going to perform. You need to work closely with the energy modeler That building was completely scaffolded and wrapped. So the whole building was covered. So there was no winter or summer on the inside. So we could just work along without worrying about the weather, which makes a huge difference. Yeah.
Yeah. And same question to you, Matteo. What pearls of wisdom would you deliver to anyone wanting to embark on a retrofit? Because they all have their unique challenges.
Oh, just do it. Yeah, work through it. Yeah, I think what Terry said is totally applicable to anything really. I mean, I wouldn't think if, well, for us, we really didn't have many options of using an external builder or contractor, and in a way, it kind of simplifies things because, well, you just have to do it yourself, and you don't have to explain it to anyone else or stay or look at what someone else is doing. But yeah, other than that, yeah, the builder has to be definitely onto it. Understand, like Terry seems, I mean, from what he's saying, is totally he has to be fully aware of what are the implications, and you see the result at the end. What they've done.
Matteo, I love your Venn diagram. I don't know if it's easy for you to pull up the Venn diagram that you did, because that sort of explains, you know, your thought processes and how you were going to make your project a reality with not necessarily huge funds.
This one.
Yeah, I think it's just fantastic, and yeah, and you've decided what was the sweet spot there.
Yeah, at the end, that's I mean, I like, be great the one to find the right spot in the middle, but well, this diagram that I borrow from the internet, that's how they call it. Sometimes they call it whatever, you are dreaming or impossible or whatever. But yeah, it is true at the end.
Yeah, fantastic. Well, thank you all so very much for sharing your expertise and your experiences and giving up your time to bring them to us. We very much appreciate that. The slides won't be shared, but the recordings will be. So Nikki will be putting these up on YouTube in the next 24 hours or so. Just to wrap up, we will be running the next webinar on the 23rd of May. That will be with Jason Quinn, and he will be talking about all things Windows. So put that in your diary. It'll be the details will be up on the PHINZ website. And yeah, anyone who's not a PHINZ member, do consider supporting us with a membership. It really helps us make this kind of thing happen. And thank you all so very much for coming. I'll leave you to the rest of your evening. Good night.
Thanks all.
Thank you.